Go ahead, Stephanie.
I chose to do my presentation on Vietnam. I chose this region because I'm interested in Asia and I wanted to learn more about the structures and like how the mountains were formed there. And I narrowed it down to Vietnam because it was a country between both land and water, and I thought it would be interesting to see like what kind of structures were formed there and how much tectonic activity was there and still is there today. And I found that it used to be very tectonically active, but more recently it's not at all, and there's very minor seismicity. Vietnam is located along in Southeast Asia, along the South China Sea and the Gulf of Tonkin, and the bordering countries are Cambodia and Laos. There are many structures that exist throughout the country of Vietnam, and they're both large and small, and there are a lot of mountains and fault lines and unconformities that are found there. And Vietnam is found on the Sunda plate, and the plate is right here, and they found that recent scientists discovered this plate because it was moving at a different way than the Eurasian plate, and it's surrounded by subduction zones. And a lot of this was it was like, I don't know how to say it, created by the Indonesian orogeny, and that was in the late Permian, early Triassic, and it was a major deformation event, and the upper Triassic red beds formed on older metamorphic rocks, and it's more found in northwestern Vietnam. I looked at different places individually, and the Red River Shear Zone is in northern Vietnam, right along there. And there was two tectonic activities that occurred. One was in the Triassic, one was in the Tertiary, and it is currently a present-day boundary, and it is one of the largest strike-slip faults in Southeast Asia. And there's vertical strike-slip shearing of the Red River Shear Zone occurred after metamorphism and granite emplacement because heating alone could not result in the high-grade metamorphic conditions. And so because of that, there's a lot of like mafic and ultramafic rocks, such as the granites and basalts and gneisses that are there. And it is currently inactive. The Dai Nui Coin Boy, that is the southernmost of four metamorphic segments of the Red River Shear Zone. And there are four major deformation events that occurred to create this fault zone. In the first, there was northeast-southwest striking shortening event in the Indonesian orogeny, which is right there. It was pushed together. And then the second deformation event was the most dominant, and it folded into sub-horizontal axial planes. And that lasted 28 million years after the orogeny. And then the third one was the youngest sextile deformation, and that created a lot of doming in the structures. And then the fourth was a brittle deformation, which created a lot of left lateral fault lines. And then here you can see how the deformation changed over time and the difference in the stresses in each event that occurred. And then the Trankstone in Quantum Massif, they accounted for shearing movements along the northwest to west trending zones, and the Trankstone belt had ultramafic and mafic rocks, so it had elements of the ophiolitic belt, which contains peridotite, pyxionite, gabbro, amphibolite, and granite. And the rocks were tightly folded and affected by penetrative ductile deformation, and they were folded northwest in an antiform, and they were viewed as a transform boundary subduction beneath the southwest China block during the Permian era. And then it is broken into different fault zones, and I looked at two, which were the Sangma and Sangfa, and the Sangma had ultramafic and mafic rocks, and the Sangha was located in the Permian early Triassic, and it also had mafic and ultramafic rocks, and it was remnants of an oceanic basin or continental rift. And then there's the Sangma right there, which you can tell it's striking northwest and dipping to the southwest. On the Quantum Massif represented an uplifted block. It was the largest exposure of continental crust of Precambrian age in South Central Vietnam. It was covered by Mesozoic red beds intruded by Cretaceous granites. It contained high-grade metamorphic and igneous rocks, and it was the core of the Indochina block. And then southern Vietnam had northeast faults control the shape of southern coast of Vietnam, and the strike-slip faults didn't affect the Neogene quaternary basalts, which are cut by normal faults. And the direction of extension of these faults was east to west to northeast to southwest. And the dominant faults are right lateral, and they were often injected by basalt, which was aged from the Miocene to present. That's all.
Oh my God.
Questions for Stephanie? That's some pretty complex structural geology and tectonics.
Yeah, I was really confused.
Where, the people who are studying it, where are most of them from?
Vietnam and stuff, so like a lot of the stuff was in different languages.
In French,
and
probably.
No, it was like in Chinese or something. Like, I don't know, Asian. And I didn't know what it was talking about.
Vietnamese people.
And yeah, that's what came up when I typed in Vietnam rocks in Google. But that's not a rock, but.
Vietnam rocks.
Stephanie, you're the best.